Hi, my name is David Johnson. I'm a senior software engineer and researcher at the University of Utah. I'm going to talk about the work that we in Keysight Technologies did to integrate Keysight's RICtest software into Powder's Lab-as-a-Service automation framework for ORAN test automation. At the University of Utah, we've been providing zero-cost remote access to research infrastructure for many years through a variety of testbed facilities, and automation has always been a big part of that, all the way from the testbeds orchestrator that takes as input the user's test requirements and maps that to real resources, to the ability of the user to automate configuration and runtime of their tests. This exercise is part of our ongoing, more focused effort to increase the number of automated ORAN building blocks that we provide and to expose them in our developing workflow-based automation framework so that we can automate ORAN testing and to quickly and repeatably stand up complicated end-to-end ORAN scenarios on demand. The approach that we took was to utilize the Keysight RICtest software, which provides testing of an ORAN near real-time RIC and its associated xApps and RApps, to instantiate that in the Powder platform, which provides mobile wireless research equipment and software. The system that we'll be testing with RICtest is an updated version of the ONF's SD-RAN near real-time RIC and its associated KPI on xApp. The outcomes of this work are the development of automated CI-triggered workflows executed by a workflow engine that test SD-RAN using RICtest software. This has allowed us to validate our updated SD-RAN RIC via RICtest, including E2AP v2 procedures and KPM v2 indications and subscriptions. And then we've provided both RICtest and SD-RAN as components that can be reused in workflows. Either the user can reuse these workflows in whole or can take the sub-components that make up these workflows and use them to create other scenarios. The figure on the left shows the realization of this scenario in the ORAN architecture. So the system under test is the ONF SD-RAN near real-time RIC and the KPI on xApp. And Keysight's RICtest is emulating RAN nodes with E2 interfaces and also emulates the O1 interfaces of those. Provides traffic models and emulated UEs as well. The figure on the right shows how, at a very high level, how this use case is stood up inside of the Powder research facility. At the top, the user is given a private instance of Powder's Lab-as-a-Service automation framework that runs inside of a virtual machine, which can then control and configure and orchestrate both the RICtest testing software deployed in a VM on Powder resources and the ONF RIC deployed inside of Kubernetes on top of bare metal. The workflow connects those resources dynamically, runs the tests, and collects outputs across a parameter space and iterates through that parameter space. This figure shows a brief overview of the Powder platform and the resources in it. Powder is designed to provide a variety of mobile wireless research facilities, all the way from the RAN through the core. It's federated with Cloud Lab and provides access to hundreds of powerful bare metal compute servers, as well as software-defined radios and COTS hardware inside of the RAN. We provide a wide variety of both software and hardware building blocks that can be easily reinstantiated by users on demand and composed as part of scenarios. And we're pushing forward Powder's ability to provide automated building blocks in this work. Keysight's RICtest software is designed to test the near real-time RIC and xApps and RApps by emulating the E2 and O1 interfaces of RAN nodes, such as ODUs, OCUs, or GNodeBs, using ORAN standards-based implementations. RICtest tests both platform and transport aspects of the RIC at scale. It also provides a very configurable traffic model and provides access to key performance measurements over the E2 interface via service models and also on the O1. And this allows users to test and validate both xApps and RApps in addition to the RIC. RICtest is a virtualized software solution that can run in the cloud, and it provides a RESTful API that can be used to configure all properties of a test including the configuration of the RAN nodes that it's emulating in the UEs and the properties of the emulated traffic model, and allows the API user to launch tests, monitor test status, and to collect KPIs, test results, and logs. This slide provides a brief overview of Powder's automation framework. The environment is itself packaged as a Powder building block that can be instantiated on demand to provide a per-user isolated environment for running tests and collecting outputs. At a high level, the framework exposes Powder building blocks and APIs in workflow and configuration management systems. It's based on well-known COTS tools, including the StackStorm workflow engine, Ansible configuration management, and the Kiwi test case management system that can collect test outputs. Once Powder stands up an instance of this environment for the user can then trigger ORAN test workflows within their StackStorm instance. StackStorm workflows are designed to invoke actions on a wide variety of resources, which allows workflows to orchestrate actions across nearly any kind of hardware or software that might be part of an ORAN test scenario. We've written custom StackStorm plugins that invoke the Powder API to instantiate our building blocks on real resources, plugins for Ansible allowing tighter and easier replayable runtime configuration of Powder resources, and to create test plans, capture outputs into test executions inside of Kiwi TCMS for preservations and later review. We anticipate that the first steps of many workflows will be to allocate resources via the Powder API using Powder building blocks, but subsequent steps may vary according to the requirements of the test software and systems under test, and could then be replaced by other existing components that the user might bring. But in this case, the steps are roughly steps 2 through 4 to provide configuration management automation to reconfigure systems according to the parameters of the current test, to actually execute a test suite, perhaps using the robot framework, and finally in step 4 to capture the outputs from these tests. This figure shows the flow of the automated RIC testing that we'll be showing in the demo video. An instance of the Powder automation framework running the StackStorm workflow engine drives these tests and triggers the ORAN testing workflow. And the workflow is basically going through the steps is to stand up an instance of RICtest or use an existing one, create an ORAN experiment or use an existing one, then use Ansible and the Powder-generated entry points to automatically reconfigure Kubernetes and the SD-RAN near real-time RIC according to the parameters of the test, and then to reconfigure the RICtest software using the RICtest remote API. Then we can invoke the Powder APIs to connect the experiments, execute a test, and then save test results into the Kiwi test case management system. Now we'll actually run this demo inside of Powder. Please watch our companion video for that. Thanks.